I want you to do something for me, just for a second. Sit incredibly still. Don't move a muscle. Hold your breath if you have to.
Okay. I'm doing it. I'm still...
You feel it.
Feel what? The air conditioning.
The motion, the rotation. Because right now, while you're sitting there feeling perfectly calm, the Earth is spinning at something like 1,000 miles an hour.
Right. At the equator, yeah.
And at the same time, it's orbiting the sun at 67,000 miles an hour.
Which is already a number I can't really comprehend.
And it gets worse. The sun is dragging our entire solar system around the center of the galaxy at, what, 500,000 miles an hour?
Something like that, yeah. When you put all the numbers together, I think I need to grab the table to keep from flying off.
Exactly. We are living in a universe that is, for some reason, just obsessed with spinning. Everything spins.
Everything.
Atoms spin, planets spin, galaxies. They're these giant, beautiful spinning pinwheel. Even black holes spin. And the question that has always bothered me, and I think it bothers anyone who really stops to think about it, is just why?
Who gave it the first push?
Yes. Who pushed the merry-go-round?
It is the fundamental question of angular momentum, isn't it? In the standard model, the one we all kind of learned in high school, it's a bit of a mystery.
It is.
You have the Big Bang, which we're all taught is this explosion outward from a single point.
Right, a dot.
An explosion is radial. It pushes things out in straight lines. It doesn't inherently make things spin.
Right. If I set off a firecracker, the pieces just fly away from the center. They don't start doing pirouettes on the way out.
Precisely. So, to explain the spin we see absolutely everywhere, classical cosmology has to kind of add it in later. It's an afterthought.
Well, there was some turbulence here, a collision there.
Exactly. Random chance events. But what if the spin wasn't an accident? What if the rotation was baked into the very geometry of the universe from the first, the first microsecond of its existence?
And that is the cliffhanger we are dangling off of today. Because the research stack you've brought in, it's heavy. And I don't just mean the page count. It proposes a complete rewrite of that Big Bang image we all have in our heads.
It really does. It challenges the whole idea of the point.
The singularity, the little dot that contained everything.
Right. We're so used to thinking of the universe starting as a dot that exploded. But this theory, which is centered around a really fascinating paper called The Genesis of Existence, a physical theory of universal formation, suggests something totally different.
What's that?
It's just the universe didn't explode.
Yeah.
It flowed. It morphed. And it didn't start as a ball or a point. It started as something, something much stranger.
And it ended up as a shape that, frankly, sounds more like a breakfast pastry than a cosmos.
We were talking about the cosmic donut.
The torus. The giant cosmic donut.
The torus.
Yes.
I have to admit, when I first saw the diagram in your notes, this giant, spinning, fiery donut that supposedly contains all of space and time, I actually laughed out loud.
I think most people do. It looks like something out of The Simpsons, but then I started reading the math behind it, the high-energy physics, the topology, and it's terrifyingly plausible.
It is. And the donut isn't just some quirky shape they picked. It's a solution. It solves very specific physical problems that the explosion from a point theory really struggles with.
Like the spinning.
It explains the rotation, yes. It also gives a reason for the large-scale magnetic fields we see. And most importantly, it explains how we get from nothing to something without, breaking the fundamental laws of thermodynamics.
Okay, but to get there, to get to the donut, we have to go back. Way, way back. Before the stars, before the galaxies, before the donut itself even formed, we have to go right to the moment of Genesis.
It's step one.
And this is what I want to do today. I really want to trace this timeline because the paper breaks it down into this majestic, almost violent sequence of events. A story, really.
It really is a physical journey, from the vacuum to the void, then to the fire, and finally to the flow.
So let's start at the absolute bottom, step one, the nothing. Because I think most of us, when we picture the beginning of the universe, we picture a black screen, just empty.
A void. Total silence.
Right. If I take a box and I pump all the air out and I shield it from all radiation and I cool it down to absolute zero, I have nothing in the box.
See, that's our intuition. That makes perfect sense. But then quantum field theory, QFT, comes along and says, actually, you're completely wrong.
What do you mean?
There is no such thing as empty.
Okay, you have to unpack that because my box looks and feels pretty darn empty.
It looks empty to our macroscopic eyes, but if you could zoom in way down to the quantum level, that empty space is a seething ocean. That's really the best analogy for it.
An ocean.
Imagine you're in the middle of the Atlantic during a hurricane. The water is churning. Huge waves are crashing. Deep troughs are opening up. It's chaos. Now imagine you could magically remove all the water molecules, but somehow you keep the motion.
A motion remains without the water.
The fields remain. The fundamental fields of the universe, the electromagnetic field, the electron field, the quark fields, they're all still there, permeating that empty box. And they are fluctuating. They're vibrating constantly.
Okay.
This is what physicists call the quantum vacuum, or, a more evocative term, the quantum foam.
Foam makes it sound kind of gentle, like a bubble bath. This sounds more like a chaotic maelstrom.
It is chaotic. It's a state of maximum turbulence. And this is where the famous Werner Heisenberg enters the chat. You know his uncertainty principle?
Vaguely. I know it means we can't measure things perfectly at the same time, something like that.
Roughly, yes. But one specific version of it says you cannot know the exact energy of a system and the exact time duration of that system with perfect precision simultaneously. There's a built-in fuzziness.
A wiggle room.
A wiggle room. And that fuzziness in reality creates a loophole in the conservation of energy.
A loophole? I love loopholes. What does this one do?
It's the ultimate loophole. It allows the universe to borrow energy from the vacuum. You can literally summon energy out of absolute nowhere as long as you pay it back very, very quickly.
Hold on. This sounds like a kind of cosmic financial scam. So I can walk into the First National Bank of the vacuum, grab $1 million of energy, and just walk out.
You can grab the $1 million, yes. But the universe's security guard is standing right at the door, and he's going to tackle you in something like a femtosecond. You have to put the money back before anyone officially notices it was gone.
So what happens in that split second where I'm holding the cash?
In that split second, something amazing happens. Virtual particles appear.
Virtual, meaning not quite real.
Exactly. Pairs of particles, matter and antimatter.
Yeah.
An electron and a positron, for example, pop into existence using that borrowed energy. They blink on, they exist for a fraction of a heartbeat, and they immediately crash back into each other, annihilate, and vanish.
And the debt is paid.
The debt is paid, the energy goes right back into the vacuum. It's a zero-sum game.
And this is happening everywhere, right now, in this room.
Everywhere. Inside your own nose, in the vast empty space between stars, at the very edge of the observable universe. It is a constant boiling simmer of creation and destruction, blinking on, blinking off, a constant roar of potential.
So the nothing that the universe started from, it wasn't a dead silence. It was this incredible roaring noise of possibilities.
Exactly. It was a state of maximum chaos. It had incredibly high energy, but it was all completely random. So statistically, on average, it all cancels out to zero. But locally, moment to moment, it's a complete mess.
Okay, so we have this soup, this quantum foam. But we don't have a universe yet. We just have these ghost particles appearing and then immediately disappearing.
Correct.
If they always pay back the debt, if they always annihilate each other, how does anything permanent ever get made? How do we get the actual stable matter that makes up my chair or the sun or us?
There is the billion-dollar question, isn't it? How do you make the virtual real? How do you steal the money from the bank and actually get away with it?
You run for the border.
In physics terms, yes. You need to separate the partners. When a particle and its antiparticle pop into existence, they are drawn to each other like magnets. They want to recombine. They want to cancel out.
So you need to stop them.
To keep them, you have to rip them apart so fast and so violently that they can never find each other again to annihilate.
You need a cosmic divorce lawyer.
You need a force, a massive, overwhelming force. And this brings us to a mechanism that was predicted decades ago called the Schwinger effect.
Schwinger. That's named after Julian Schwinger, the Nobel laureate.
The very same, yes. Back in 1951, he proposed something that sounded like pure science fiction at the time. He did the math and calculated that if you applied a strong enough electric field to a vacuum, just pure empty space, the field itself would have enough power to physically rip those virtual particle pairs apart.
Wait. So you're saying electricity can literally turn nothing into something?
The electric field pays the energy debt. It gives the particles enough of an energy kick to become real, to become permanent. The field loses a tiny bit of its own energy in the process, and in exchange, the vacuum spits out real, stable electrons and positrons.
That is absolutely wild. Have we done this? Have we built a machine that makes matter out of nothing?
We are getting so close. At places like the Extreme Light Infrastructure Facility, they're using massive lasers to create incredibly high-intensity fields. We are right on the verge of experimental verification.
So what's the holdup?
The sheer amount of energy required is just staggering. We are talking about 1.3 times 10 to the 18 volts per meter. That is a number so ridiculously high, it makes a lightning bolt look like a single AA battery.
Okay, so in the lab, we need these gigantic lasers. But at the very beginning of the universe, there were no lasers. There was no machine. So where did this incredible force come from to rip the vacuum apart?
It came from the chaos itself.
The foam.
Remember the foam. It's a chaotic ocean of random waves of energy constantly rising and falling.
Right.
Well, if you have an infinite ocean of random waves for an infinite amount of time, eventually, just by pure statistical chance, you're going to get a rogue wave.
A rogue wave, like in the perfect storm, the one that sinks the boat.
Exactly like that. You get one infinitesimally brief moment where a trillion little random ripples all happen to sync up perfectly. They overlap. It's called constructive interference. They all pile on top of each other to create a single massive universe-birthing spike of energy density.
The spike.
The spike. The paper theorizes that this is the spark of Genesis, a random fluctuation where, for a fleeting instant, the energy density in one tiny patch of the vacuum hit the Planck limit.
I saw that number in the notes. It was 10 to the 113 joules per cubic meter. I can't even process that.
Nobody can. It's a number that basically breaks physics as we know it. To put it in perspective, it is 10 to the power of 90 times denser than the center of an atomic nucleus.
My brain just shut down.
It's a density where the vacuum itself literally cannot hold itself together anymore. It becomes unstable. It fractures. The vacuum undergoes what we call a phase transition.
Like water boiling and turning into steam.
Exactly like water flashing into steam, but infinitely more violent and energetic. The fabric of the vacuum breaks down, and to relieve that insane pressure, it dumps all of that pent-up energy into creating mass. It pays the debt for trillions upon trillions of virtual particles all at once.
So that's where E equals mc squared comes in.
In its most dramatic and spectacular display, the raw energy of that spike converts directly into a primordial plasma. Top quarks, gluons, Higgs bosons, suddenly they aren't virtual anymore. They are real. They are stuck here with us. The cosmic bank has been robbed, and the robbers are loose in the streets.
So let me see if I have this straight. We are, essentially, we're made of frozen vacuum energy.
That is a beautiful way to put it. We are. The matter in your body is just a crystallized result of that ancient energy debt being paid by a collapsing field. We are the debris of a broken vacuum.
That is both incredibly poetic and slightly disturbing.
It's a transition of form, not a creation from absolute zero.
Yeah.
The potential was always there in the foam.
Okay. Wow. So now we have matter. We have a gigantic, super hot blob of plasma. But a blob isn't a donut. A blob is just a blob. How do we get structure out of this primordial soup?
This is where the sculptor steps in. And the sculptor's name is gravity.
Gravity finally wakes up.
Gravity was always there, of course, waiting in the wings. But gravity needs mass to act upon. Now that we have this enormous cloud of plasma, gravity starts to act on it. And it starts looking for imperfections.
Imperfections? I thought it was a uniform soup.
Almost. But not quite. Remember, it was born from random quantum fluctuations, so some spots were a tiny, tiny bit denser than others. The difference was minuscule, maybe 1 part in 100,000. But for gravity, that's all it needs.
Gravity sees that slightly denser spot and says, ooh, I want that.
It pulls. It attracts more matter from the surrounding regions to that spot, which, of course, makes that spot even denser, which in turn creates an even stronger gravitational pull, which pulls in even more matter.
It's a runaway effect. The rich get richer.
It's a classic feedback loop. But the notes you saw mention a battle. It's not just gravity pulling in unopposed. Something is pushing back.
Pressure.
Exactly. This stuff is hot. It's unimaginably hot.
Yeah.
And that heat creates immense radiation pressure that is constantly pushing outward. So you have gravity trying to pull everything in and collapse it, and you have pressure trying to push everything out and expand it.
What happens when you have those two colossal forces fighting each other?
You get a bounce, a vibration.
You get a vibration. You get sound waves. Yes, sound waves. In the early universe, there was sound.
Not sounds you could hear with your ears, but acoustic waves, yes.
Yeah.
Massive pressure waves rippling through that plasma cloud. The entire universe was, in effect, ringing like a giant cosmic bell that had just been struck. These waves are traveling through the fireball, compressing matter in some places and rarefying it in others.
So the early universe was incredibly loud.
Deafeningly loud, if you could have been there. But these sound waves did something absolutely crucial. They created the blueprint for everything that came after.
How?
Well, where the crests of these waves collided, constructive interference again, they created zones of extremely high density. And where the troughs of the waves met and canceled each other out, they left behind vast empty voids.
This is the cosmic web structure we see today, right? With the filaments of galaxies?
Exactly. The vast filaments of galaxies and the giant empty voids between them. Those are the frozen echoes of the sound waves that rippled through the plasma in the first moments of creation. We're living in a fossilized sound wave.
Okay, my mind is already blown and we're only on step 3. So we have a web, we have a lumpy, vibrating soup. But we still don't have the shape, we don't have the bicone or the torus yet, we just have a chaotic mess. How do we get from this web to a specific geometry?
This brings us to the most dramatic moment of all. The moment of symmetry breaking. This is step 4 in our outline, and it's where the universe makes a choice.
Symmetry breaking, this is where I always think of the pencil analogy.
It's the classic one because it just works so perfectly. Imagine a freshly sharpened pencil balanced perfectly vertically on its tip.
Okay, got it.
It's perfectly symmetrical, it looks the same from every possible angle, all the forces are balanced. But it's an incredibly unstable state.
It can't stay there forever. A tiny breath of air, a vibration from the floor, it has to fall.
And when it falls, it has to choose a direction. It can't fall in every direction at once. It falls north or south or east or west. The moment it starts to fall, that perfect symmetry is lost forever. A specific direction is chosen.
And the universe did the same thing.
The entire cloud of primordial matter had to collapse. Gravity was ultimately winning the war against pressure. But it couldn't collapse perfectly symmetrically from all directions at once. Just like the pencil, it had to fall in a particular direction. It picked an axis.
A north and south pole for the whole universe.
Yes, a polar axis. And once that axis was established, the collapse wasn't just a general uniform shrinking anymore. It became a structured flow. The paper calls it bipolar condensation.
Explain that flow. What does it look like? I'm trying to picture it.
Okay, picture that enormous sphere of plasma and gas. Now imagine that gravity is pulling everything toward the center, but it's funneling it, channeling it specifically along that newly chosen north-south line.
So it's not shrinking like a balloon losing air.
No. It's more like you have a massive river of matter rushing down from the North Pole toward the center, and at the same time, another identical river rushing up from the South Pole toward the center.
They're on a collision course. 2 cosmic freight trains heading for the same spot.
And they're accelerating to near the speed of light as they fall into this immense gravitational well. The energy involved here is beyond any scale we can comprehend. And where do they meet?
Right in the middle. The equator.
The equatorial plane. And this isn't a gentle merger. This is a cataclysmic crash. A hypervelocity collision of unimaginable density and temperature. When those two streams hit each other head-on, the material can't just stop. It has to go somewhere. It splashes. It compresses.
And this creates the shape. The one in the notes called a bicone.
Right. Think of 2 ice cream cones, but you've touched them tip to tip. The wide open parts of the cones are the massive flows of matter coming in from the north and south, and the sharp tips meet right at the center of the universe.
Okay, I have the image. It looks like an hourglass. A cosmic hourglass.
An hourglass is a perfect analogy. But here's the fundamental problem with an hourglass-shaped universe. That point. The point where the grains of sand meet. Yeah. That tiny microscopic pinch point in the middle in physics, that's a nightmare scenario.
Why is that a nightmare?
Because it represents a singularity. If all of that infalling matter crashes into a single infinitesimal point, the density goes to infinity. The curvature of space-time goes to infinity. The laws of physics break down. The math just stops working. And nature, as a general rule, absolutely hates singularities.
Right. Nature doesn't like sharp edges or infinite points.
Nature prefers smooth curves. It always seeks to find the path of least resistance, the state of minimum energy. And shoving the entire mass energy of the early universe into a single point is a very, very high-energy, unstable state. So this theory argues the universe found a way out. It cheated.
It cheated. How?
It changed its own topology. It underwent what the paper calls a topological metamorphosis. This is the absolute core of the whole theory. This is the moment that transition from bicone to torus.
Okay, you have to walk me through this slowly because my brain is trying to turn 2 cones into a donut and it's starting to hurt a little.
Okay, let's visualize it. You have the 2 cones meeting at that infinitely sharp point. The pressure is building to unimaginable levels. The temperature is in the trillions of Kelvin. The very geometry of space-time is screaming. So instead of collapsing all the way down into a dot, that central point, it opens up.
It opens like Like an eye.
like a camera aperture opening, or like the throat of a funnel suddenly widening. The sharp singular tip expands outward into a ring, a circle.
Whoa. Okay, so the waist of the hourglass gets fatter.
It expands until it's no longer a point, but a hole, a tunnel going through the center. Now, the matter that's flowing down from the north doesn't hit a solid wall anymore. It flows through the hole.
And out the other side.
It passes through the center, curves around the bottom, travels up the outside of the structure, and then gets swept back into the flow at the top.
It becomes a loop, a continuous cycle.
It becomes a smoke ring. That is literally what a smoke ring is, a toroidal vortex. The air rolls through the center and wraps around the outside. The universe, on the grandest scale imaginable, did the exact same thing to save itself from the singularity.
So the donut shape, the torus, it wasn't just a random accident of geometry, it's a mechanism. It's the only way to keep the flow moving without everything crashing into an infinitely dense point.
Precisely. It turns a head-on collision into a stable circulation. It turns a crash into a cycle. And this is a much, much more stable, lower energy state for the system to be in. Once that central channel opens up, the matter establishes a permanent flow pattern. It follows what we call geodesics, the natural curved paths in spacetime that wrap around and through this new toroidal surface.
So we are right now living inside a giant cosmic smoke ring.
We are living in the flow of a giant cosmic smoke ring that has been expanding and rotating for 13.8 billion years.
Okay, you said the magic word, rotating. This has to go back to my vertigo at the beginning of the show. Why does the donut shape naturally make everything spin?
This is the elegant beauty of it. This is step 6 in our roadmap, confinement and rotation. Think about the shape of the torus for a second. It's a natural trap.
A trap. How so?
It's a gravitational and topological trap. Matter and light can circulate inside this donut shape almost endlessly. It's a closed loop. There's no easy way out.
Okay.
And when you confine that much energy and you have that continuous flow through the narrow center, you automatically trigger one of the most fundamental laws of physics, the conservation of angular momentum.
The figure skater.
The figure skater.
Yeah.
It's a perfect analogy. When she is spinning with her arms outstretched, she's rotating at a certain speed. But when she pulls her arms in, she spins much, much faster.
Right.
Why? Because she's conserving her angular momentum as her radius of rotation shrinks. In the torus, as matter flows from the wide outer edge through that narrow central hole, the throat of the donut, it is being squeezed into a much smaller radius.
So it has to speed up.
It has to speed up massively. This creates what astronomers call differential rotation. The inner parts of the torus are spinning much faster than the outer parts. This sheer force, this twisting motion between the inner and outer layers, this is the engine of the universe.
So the torus itself is the dynamo, the great engine.
It is the great rotator, and this is the part that just blows my mind. This primary rotation of the whole universe trickles down. The big rotation causes turbulence in the flow. It creates little eddies.
Like little whirlpools in a river when the water speeds up.
Exactly. And what do you think those cosmic whirlpools are?
Galaxies.
They're proto-galaxies. A galaxy is nothing more than a localized vortex in the greater flow of the toroidal universe. And then inside that spinning galaxy, smaller eddies collapse under their own gravity to become solar systems. And inside those, the conservation of momentum continues as a cloud collapses into a star and a spinning protoplanetary disk.
So the reason the Earth spins, it isn't because something big and random hit it billions of years ago. It's because it was born from a spinning cloud of gas.
Which was born from a spinning galaxy.
Which was born from the fundamental spinning of the donut-shaped universe itself.
It's a direct lineage of spin. We are spinning because our great-great-great-grandfather, the universe, is spinning. It's inherited motion passed down through the generations.
Yeah, it makes me feel incredibly connected, but also incredibly, incredibly small.
Oh, just wait until we talk about the timescales. Because if you feel small now, just you wait.
Oh no, I saw the numbers in the last section of the notes. The section ominously titled Deep Time.
The torus is stable. It's an incredibly efficient and long-lasting structure, but nothing lasts forever, not even the universe. The second law of thermodynamics, entropy, eventually comes for everyone and everything.
Things fall apart. The center cannot hold.
The flow eventually loses its coherence. Energy spreads out. The structure starts to decay. But the time scales we are talking about for this to happen, we aren't talking billions of years. We aren't even talking trillions.
The paper mentions 10 to the power of 1,000 years?
10 with 1,000 zeros after it.
Okay, I need a moment to just process that number. A billion has 9 zeros. A trillion has 12. A Google, which is already a famously huge number, has 100 zeros.
And we are talking about a number with 1,000 zeros. If you tried to write this number out, and you wrote a 0 on every single atom in the entire observable universe, you would run out of atoms long before you ran out of zeros to write.
It's just an absurd number. It's effectively eternity.
To a human mind, yes. But to the cold, hard math of physics, it's just a duration. And at the end of that unimaginably long duration, the theory says the torus finally destabilizes. Gravity, the one force that never quits, takes over again. The hole in the donut closes up. The structure begins to collapse back inward.
Big crunch.
The great collapse. Everything rushes back towards the center. The galaxies, the burnt-out stars, the stray particles, the last photons of light. It all falls back into the fire from whence it came.
And then what? It hits the singularity and just ends. Game over, lights out.
Well, that's the beautiful part of the theory. The punchline. Remember what happened the very first time? When the bicony tried to collapse and the density got too high.
The vacuum got excited, it became unstable, the quantum foam came back.
Exactly. As the entire universe crushes back down to that tiny Planck scale, that 10 to the minus 35 meters quantum gravity effects take over again. The geometry gets fuzzy. The vacuum once again reaches that critical point of volatility.
And it bounces.
It bounces. The energy of the collapse fuels a new expansion. A new phase transition occurs. New matter is created from the super-excited vacuum. A new bicone forms from the ashes. A new torus opens its central channel. And a new universe is born.
The eternal return.
It's what Nietzsche talked about from a philosophical perspective. The idea that time isn't a line, but a flat circle. Or in this case, a three-dimensional donut that collapses and rebirths itself. It implies that all of this, has happened before.
So, in a previous cycle, maybe 10 to the 1,000 years ago, did two people who were functionally identical to us sit in a room that was identical to this one and have this exact same conversation?
If the universe is truly infinite in duration, and the laws of physics are constant, then statistically, yes. Every possible configuration of atoms must eventually repeat itself. We have had this conversation an infinite number of times before, and we will have it an infinite number of times again.
I honestly don't know if that's comforting or terrifying.
I think it's a bit of both. It means we're kind of trapped in a cosmic loop, but it also means we're sort of immortal. The pattern that makes up you never really goes away for good. It just waits for the next cycle to reassemble.
Okay, let's take a breath. We have gone from the quantum foam all the way to the heat death of the universe and its rebirth in about an hour. I want to try and bring this back down to earth for the listener. Why does this actually matter? I mean, it's a fascinating story, but I still have to pay my taxes. I still have to go to the grocery store. Whether the universe started as a dot or a donut, does it change how I live my Tuesday?
It might not change your Tuesday errands, but it should absolutely change how you look at the night sky.
How so?
Think about something we touched on briefly. The idea that light can travel in loops. If the universe is a torus, light can wrap all the way around it.
Right. It can circle the donut and come back to where it started.
So when you look up at a very, very distant galaxy through the James Webb Telescope, a galaxy that appears to be billions of light years away, you might not be looking at a stranger. You might actually be seeing the Milky Way.
Wait, I'm seeing our own galaxy.
You could be seeing light from our own galaxy as it was 10 billion years ago. The light left us, traveled all the way around the curve of the universe, and is now hitting us in the back of the head.
So the night sky is a hall of mirrors.
It could be. A cosmic funhouse mirror. You might be seeing multiple reflections of the same cosmic history from different angles and different times. It challenges the whole idea that out there is fundamentally different from here. It's all one connected, looping surface.
That actually makes the universe feel a lot more intimate. It's not this cold, infinite, expanding void. It's a room, a really, really big room, but a room nonetheless.
A room with a very specific and elegant architecture, and we are just now beginning to understand the layout of the furniture.
Well, I can tell you one thing for sure. I am never going to look at a glazed donut the same way again.
It really might be the fundamental shape of existence.
You know, it's funny. We started this deep dive talking about feeling small and dizzy, about being the random debris from a cosmic explosion. But this theory, the flow, the connection, the eternal bounce, it actually makes me feel like we're part of a living thing.
A respiration.
Yeah.
The universe breathes in and the universe breathes out. We are just living in the long, slow exhale.
We are living in the exhale. I love that.
Just remember, the inhale is coming. Eventually.
In 10 to the 1,000 years, I think I have time to finish my coffee.
You have time.
Thank you so much for walking us through this. This was Incredibly dense, but absolutely
It
fascinating.
was my pleasure. It's good to stretch the old brain topology every now and then.
Absolutely. And to everyone listening, next time you feel the world spinning a little too fast, just remember, it's supposed to. You're just riding the flow of the cosmic donut.
Keep looking up.
We'll see you in the next deep dive, hopefully in this cycle of existence.
Hopefully.
Bye, everybody.